Continuing to develop fluency around using some formulas in the 7th and 8th grade. One of those other areas where that formula begins to develop and where that understanding begins to develop is finding the distance between points on a coordinate plane. And at first, especially if you are quite fluent yourself and you recall from maybe your high school geometry class, or maybe you also teach geometry, that the way that this might be handled in a 912 environment would be going to the distance formula. And that distance formula, we take the square root of x2 minus x1 squared plus y2 minus y1 squared. And so that's the distance formula. We could use this formula plugging in these points. Which one we call 1 and 2 doesn't really matter. We could say x1 and y1, x2 and y2. However, in 8th grade, if we just jump right to this formula, we're missing an opportunity to help students build understanding of sort of where this formula comes from, why this formula exists, and what we're really doing when we find the distance between 2 points on a coordinate plane, and why 2 points like this might be a little more difficult than finding the distance between, say, 3, 8 and 5, 8. That would be a lot more simple because they sort of share one of those coordinates, and so we're just counting straight across. I know that 1, 2, these are 2 away. The distance between these 2 points would just be 2. However, when I'm looking at these 2 coordinates here, it's not a straight vertical or horizontal line, and so calculating that distance is a little bit more complex. However, in 8th grade, we're actually not going to use the distance formula, and even in the standards themselves, it calls for a very specific strategy for doing this, and that is to help build the understanding of where this formula comes from. And then when students take geometry in high school, then they can generalize this strategy, they can generalize this idea and start using the distance formula. So the way this works is sort of just by first asking the question, like, why is it difficult to find the distance between those points on a coordinate plane? And if I had a grid, if I'm counting horizontally or vertically, it's easy to see the distance between points. But when something is diagonal, both, it's changed horizontally and vertically, finding that distance isn't really countable. You can't count that as easily as you can if it's vertical or horizontal. But thinking about the fact that I do know all of the vertical and horizontal distances, I can count that. If I were to just count straight up, right, from 8 to 12, I know that that is 4. And if I were to just count straight over from 3 to 12, I know that that is 9. And so there are some distances that I do know. And because this is a perfectly vertical line, and because this is a horizontal line, I know that vertical and horizontal lines are perpendicular. I know that this is a right angle. And in 8th grade, another concept that students learn and understanding that they develop is the Pythagorean theorem, which tells us some really useful information about right triangles. And I can kind of see a right triangle here. I have these 2 lines that create a right angle, and I connect them. This distance, what I'm looking for, is actually the hypotenuse of this right triangle. So I can use the Pythagorean theorem as a strategy to find the distance between those 2 points. Because I know A and B, I know the 2 legs, I can work this out. So 4 squared plus 9 squared is going to give me C squared, C in this case being that distance that I'm looking for. So 16 plus 81, which is 97, equals C squared. And so if I find the square root of 97, which is about, I wrote 92, not 97, is about 9.6, something like that, a little less than 10. Square root of 100 would be 10. Then now I have the distance. If I needed it precisely, in 8th grade, students have access to a calculator. and they can calculate the square root of 97 if needed. But I know now that the distance to this is about 9.6 units from here to here, and that's being done without the distance formula. In fact, the distance formula is derived from the Pythagorean theorem, and so in high school, when students take geometry, they can build that understanding and build the distance formula off of the foundation that we set in 8th grade.